Hey guys, how are you doing? I hope you're doing well. Today I will be showing you how to set up NestJS with Prisma, GraphQL and Postgres as our database. And on top of this, we will build a little API with basic Crud functionality. And yeah, this will help you to make your first steps using these technologies. So without further ado, let's jump into the code. First things first, let's create a new NestJS application using this command here, nest new, and then our project name, for example, NestJS YouTube. My personal preference is here npm. And if this does not work, you need to install NestJS globally via this first command here. Let's cd into our project directory now, and then we can type code empty space dot. This will bring up Visual Studio Code, and we are already in our right directory here, NestJS YouTube. Since we want our NestJS application to be able to communicate with a Postgres database, we need to set up somehow a database connection, and we will be doing it by using Docker, because Docker makes it a breeze to spin up a database instance, so we don't need to install Postgres on our machine and stuff like this. And this is super easy. Don't get overwhelmed. We will be doing it step by step. And all we need to do here is we have to create a Docker Compose file, docker-compose.yaml. And then I just paste some stuff in. It's not much. And all we are doing here is we install one service, database. We will be using the latest Postgres image. This will install Postgres into our container, so we can run it from there. We will be using port 5432, and then these are here our credentials. So our user will be called root, the password will be 123, and here's database name. Maybe I say something like NestJS. And since we are using Docker, please make sure to install Docker Desktop on your machine. And this is how it looks like, the app. At the moment, we are not running any containers. Now let's set up GraphQL. For this, we need to install a few dependencies. You can go to the official docs of NestJS and search for GraphQL here. And then you just copy this line here. This will install a few dependencies. Then we can go into our source directory here. We can delete a few files here. We do not need the app controller test file. We do not need app controller. And we do not need app service. Then we go to our app.module and we can delete these two imports. And also we can delete the controllers and providers property here. Then we can copy some stuff. Going back to the official NestJS docs here. And we are here in our GraphQL category. We can copy this here and paste it in here. And of course, we also need these two imports. And since we want to use the playground, we can delete this and debug faults. We can also delete it. And what the playground is this thing here. It's pretty useful. We will be using it for making queries and also mutations. But first of all, we need to provide a few more properties here. So what we need to provide is this line here. And this will just create a schema file. And we need to import the join module like this. And we can also say that we want to sort the schema. So we say sort schema is true. And yeah, that's it for now. And since I want to create a little API, yeah, with basic Crud functionality, we will be creating another resource, and I will name it to do. I can create a resource by writing nest g for generate and then resource, and I name my resource to do. And here now we can choose between REST API or GraphQL. And of course we want to choose GraphQL. And we will be choosing the code first approach, meaning we write our entities, yeah, our models, and then based on these models, GraphQL will generate its schema. We could also choose schema first, but then we would have to write our schema manually. And yeah, this is not so nice. I don't like it. So let's go with the code first approach here. And for now, we say we want to have Crud entry points. Now you see we have another module here to do. And we have our resolvers here, our to-do service, and so on. We have test files here. We don't need them, so I just delete them. Yeah, that's all we need to do for our GraphQL setup. Now let's set up Prisma. Going back to the official docs of NestJS, we can search for Prisma, and the documentation here is pretty good. So all we need to do is install Prisma as a dev dependency. Next, we need to run npx prisma init. This will create a folder here called Prisma, and in it we have a schema.prisma file. And here you see the default provider is Postgres. Yeah, that is what we will be using, so we do not need to change it. And then also here's a URL property, and it points to an environment variable called database URL. And this is what we find here in our .env file. And here you see that we need to update the string, because in our docker-compose file, we said that the user should be called root, and it should have the password 123, and the database name is NestJS. So let's update the environment variable here. So the user is called root, password is 123, and database name is NestJS, like this. And now let's start up our NestJS application by writing npm run start :dev. And what you see here now is that NestJS auto-generated a file called schema.gql. And in it, we already have our schema because we chose the code first approach. And you see it generated some stuff, but at the moment it's not really useful because you see something like example field here. And why this is? It's because it generated this schema file based on our to-do entity here. And you see this to-do entity has just this example field at the moment. What we can do here now is, let's say our to-do has an ID. And we do not need this stuff here. And then it also has another field called title, which is a string. Important here, in order for GraphQL to be able to generate the schema here, we need to provide a decorator called object type here. And then also we need to provide the field decorator for each field here. And due to these decorators, GraphQL is able to generate the schema file for us. And now after saving the file changes here, let's go back to our schema.gql file. And now you see that the type of to-do is updated. It has a title property here now. But as you can see, the other things here are not updated. Update to-do input is still wrong. and create to-do input is still wrong. And this is because if we go back to our to-do module and then we go into the folder DTO, we have these two DTOs here and they still have the example field here, right? So let's change this. Whenever we create a to-do, we will just provide a title. And of course, we do not have an ID, right? Because we need to create the to-do in order to have an ID. And we do not need this stuff here. And of course, this is not an integer, so we do not need to provide this. If it's just a string, this field, then we do not need to pass anything in this decorator here. Now let's update also our second DTO here. And here it's a little bit more complicated. In order to update a to-do, we need its ID, but we also need the title. After saving the changes here, going back to our schema.gql file, we will see that everything has been nicely updated. And this is the power of the code first approach. We just write our code here and then the schema is automatically created for us. In order for NestJS to be able to communicate with our Postgres database, we will make use of Prisma as an object relational mapper. And yeah, Prisma makes it a breeze to communicate with our database. What we need to do next is we need to go to our schema.prisma file. And here we need to specify our models. And based on these models, tables in our Postgres database will be created. And for now, we will be just having one model called to-do. And this is quite simple. It will have an ID and a title. Although we have created our model here now, in our Postgres database, nothing has changed yet. And we can update our database by using this command here. I just open a new terminal window and I say npx prisma migrate dev. And then I provide a name of init because it's our first migration. I hit enter. And of course here we get an error now because we can't connect to our database. And why this is? And this is because we need to spin up our database. And this is because we need to spin up an instance of our Postgres database. We go to a new terminal window and we write down docker compose up. And this will start an instance of a Postgres database. And now we should be able to reach our database. I try it again and this works now. And it was successful. What you see here now is a migrations folder and in it we have our first migration. And what you see here is that a table was created called to-do. And yeah, it has two columns, an ID and a title. And also the ID is a primary key. So it's unique by default. Now what I will be doing is I will close all these files here. Next, we need to install another dependency. And it's the following. npm install @prisma/client. And then also let's create a separate Prisma service by writing a nest g for generate and then service, and we name it Prisma. Here it is. In the Prisma folder we have our Prisma service. And here I just will paste in some stuff. We just need to paste it in once and then it's good to go. And I got this from the official docs. So you can grab it from here. And now we can work on our GraphQL API. We can go to our to-do service.ts. All right, now let's create basic Crud functionality using Prisma. For this, we can make use of dependency injection and inject our Prisma service into our to-do service. But first of all, we need to add our Prisma service to the providers array. So in our to-do module, in the providers array, we need to add the Prisma service. Now we can go back to our to-do service. We can make use of the constructor. And we can perform our dependency injection here. So we say private Prisma colon, and then it's of type Prisma service. And now we are able to use the Prisma service in our to-do service. Okay, now we can start to implement basic Crud functionality for our GraphQL API. So here we say we want to return this.prisma.todo.create. And you see I have nice auto-completion here. Prisma knows about our to-do. And this is because we have created a to-do model in our schema.prisma file, right? Important here, for example, if you create another model here and you want Prisma to know about this model, you need to write down npx Prisma generate. Yeah, you need to write this down every time you create a new model in schema.prisma. The reason why we didn't need to do it for our to-do is because we used this command here, right? npm install @prisma/client, and this will automatically call npx Prisma generate for us. So this is why we didn't need to write this command, this generate command. All right, let's keep going. Here we have to provide a data property now, and then we can either use the spread operator and spread all the properties of create to do input in, yeah, which is just a title here for us now, or I can do title, and you see we have nice auto completion here, and then I can say create to do input and then .title like this. And you see here now that the return type of our method is prisma.prisma and then something, and this is because we need to make this an async method, and then we need to await this thing here. And now you see that the return type is a promise of type to do. Nice. Next, let's work on the find all method here. This is very simple. We just can say this.todo find many. And of course here I need to write Prisma like this. Next, let's work on our find one. Here we say this.prisma.todo find unique, and then we have to provide a constraint. So we can say where, and then we pass in the ID like this. And now this is important. Find unique expect, and this is important now, find unique expects a unique property, and since in our model we provided this ID property here, which is a primary key, it's unique by default. If we provided this title in this where property, we would get an error because this thing is not unique. And in order to make it unique, we would have to provide something like this here. This is important, but I do not do it for now. We just use the ID for now. Next, let's work on our update method here. Here we can say this.prisma.todo.update. And we can use where again. We pass in our ID. And then, of course, we also need to pass in our data. And since our to-do has just a title, we only can update the title. Yeah, that's it for now. Now also let's work on the remove method. Here we say this.prisma.todo delete. And then again we make use of where. And then we pass in the ID like this. Next I want to show you something. We can use the command npx Prisma Studio. And this will bring up this client here. And you see we have one modal called to-do. I click on it. And you see we have a table here with an ID and a title. What I want to show you next is how you can update your model. So imagine you want to have some more properties here. For example, created at and updated at like this. Then you need to run this migrate command again. Yeah, this one here. And you can provide a name. Maybe name it be edit, created at, and updated at. Hit enter. Now you see that a second migration was created and that the to-do table was changed. And basically our two columns were added. And you also see the name of our migration here that I specified. Now we can start our Prisma Studio again. And you see our table has been updated here now. Now we have created at and updated at. Alright, now I would say let's test the Crud functionality, right? So let's make use of our playground. So we just can go to localhost 3000 and then /GraphQL. Alright, let's try it out. First of all, let's create a to-do. So we have to use a mutation because every time we want to change the state on our server, right? We want to change the database. Yeah, we have to do, we have to perform a mutation. So we say mutation and then we can give it a name. The name doesn't matter here, but I call it create to do. Then I can provide arguments here and I say, and I call mine input. Important here, you need to make a $sign. And this input should be of type create. I don't know how is it called. So I can look up in the schema here. And here you see we have a create to do input. And here I need to provide this sign here. So I say this must be provided. And this name here is not important, but now I open up curly brackets. And now I need to provide this name here, create to do. And this name comes from our resolver, to do resolver. You see that we have a mutation here called create to do. So we will be hitting this method here if we use this create to do mutation. And important here, this name doesn't matter. I could also name it like this, but this name here is important now. And here now I can provide arguments and this create to do expects arguments that are called create to do input. And the value for it should be this thing here, input. Now we can open up curly brackets again. And we can provide something that we want to be returned. And we say we want to have the ID and the title. And you see we have very nice auto-completion here. Now let's run this mutation. And of course here we get an error because I made a stupid mistake. Here, right? It should be called create to do input. Now let's try it again. And again, I made a mistake. We need to provide some data, right? We want to create a to-do. So let's go down below here and pull that thing up here, query variables. Open up curly brackets and then we say input. because we named this thing input here, right? So we need to provide the same name down below here. Then again, we open up curly brackets and we just provide a title of maybe eat something healthy. And let's hit play again. And there we go. Our to-do has been created. Let's create another one. Party hard. Yeah. And it also has been created. And important here, since we are providing an input, we need to have this outer line here, right? We need to specify a name here and stuff like this. If we didn't have any input, we would not have to do this. And at the moment, you see, we just have one query to do. So this will return a specific to do. Yeah, and we have to provide an ID. But I just wonder why we have now second query called to-dos. Because in our resolver, we should have two different queries. And here you see we have a bug because we named these two queries identical, right? To do and to do. I don't know why this happened. Usually when we create a resource, NestJS does not make this mistake. So I don't know why this happened. But since we are returning multiply to-dos here, we can name this thing to-dos like this. Here you also see the return type. It's an array of to-do. All right, cool. And now if we go back to our playground here, it has already been updated and we have the to-dos query here. And here I just can say now, curly brackets, to-dos. And then I can specify what I want to return for each to-do, just the ID and the title. Let's see what we get. There we go. We get our two to-dos. And here important, you see, I just need to write it like this. I don't need to provide all this stuff here. Next, let's get a single to-do by ID. Here again, I have to provide the outer line, similar to this here. So I have to write query and then to-do. Then I have to specify the input with a $sign. And of course here, this is convention, I think. You have to provide a capital letter here. And then the input is of type int, like this. All right, cool. Then we have to open curly brackets. And then we have to use our to-do query here. And here we have to provide the right arguments now. It expects a key of ID. And then we can pass in the value, which is this input thing here, like this. And now we have to open up curly brackets again. And we have to provide the return values for the to-do, which will be the ID and yeah, the title, why not? Now we have to go down here and go to query variables. And then again, open up curly brackets, input, and then we can pass in the ID, for example, 2. Like this. And important here, this must be an integer, not a string. Hit play, and there we get our to-do. Party hard. Okay, cool. Next, let's see if the update mutation works. Again, we need to provide the outer line here, because we will have to pass in some arguments. Here again, we say mutation because we want to change the state of the server. And then we name it update my to-do, for example. And we will have an input, which is of type update to-do input here. Oops. And of course, this must be a capital letter. And we need the sign here at the end. And again, open up curly brackets and then update to do. And this update to do expects update to do input as key, and as a value it gets this thing here. Next, we need to specify a return value. We just want to have the ID and the title be returned. Again, we need to go down below here, query variables, open up curly brackets, and then input. And as input, we need to provide something here. So in this case, we need to provide an object with the ID. So we need to specify which to-do we want to update. For example, maybe the second one, right? So we provide 2 here. Then we want to update the title. So we need to provide a title here. And you see we have so nice auto completion, right? This is really amazing. And here we say, instead of partying hard, maybe we say working out hard at the gym. This might be a healthier option. And now let's hit play. And again, our to-do seems to be updated. What we can do now is go back to our to-dos query and let's get all our to-dos. And what you see here is we have our 2 to-dos and the second one has been updated. We can also have a look at our Prisma Studio here. Hit refresh and you see we have our 2 to-dos here. Finally, let's try to remove a to-do. So we write another mutation. Let's call it remove to-do. And again, it gets an input, which is just the ID. So we say int. Then we open curly brackets, choose remove to-do. And based on our schema here, remove to-do expects an argument with the key of ID. So we say ID colon and we pass in our input variable here. We open up curly brackets again and we return the ID, for example. Let's go down below to our query variables, open up curly brackets and then choose input. And then as input, maybe let's choose 2. So we want to delete the to-do with the ID of 2. Hit play. And there we see it was successful. Now let's go back to to-dos and hit the queries to get all our to-dos. And of course we only get the first one because we deleted the second one. Alright guys, that's it. This was a basic tutorial teaching you how to set up NestJS with GraphQL, Prisma and a Postgres database. I hope it was a little bit helpful. Thank you so much for watching. See you in the next video. Bye for now.